Good afternoon, ladies and gentlemen. I would welcome you to our next stop of our lab tour. My name is Sascha Naumann and I'm part of the group of material diagnosis. And today I want to show you the application of computed tomography to analyze the degradation of heart valve bioprostheses. As you already know from the presentation of Dr. Beschasner, this type of prosthesis shows a very unique type of degradation called calcification. And to accelerate this type of degradation, commercially available heart valve durability testers are used. And after accelerated load of such heart valve, it's necessary to investigate the properties of such heart valve. And this can be done by MicroCT. This is our MicroCT system. It consists of a 225 kilo-electron volt microfocus tube with a cone beam, this 9-axis manipulation system, and this scintillator, this scintillation detector with 2000 by 2000 pixels and a carbon window. With this manipulator, we move the sample. In case of today, this sheet of tissue of a heart valve. We move the sample into the beam path. For a complete tomography, we have to rotate the sample 360 degrees. And after each partial step, we got a 2D image called radiography. And so we got 1,600 single images. And after we collect all these images, we are able to reconstruct a complete 3D volume. With this setup, we are able to reach resolutions down to 2 micrometers, and we are able to investigate a very huge range of samples. For example, historical treasures or microelectronic or welding seams. To show you how it works, I have to leave this chamber and close the door. Okay. Now we can switch on the X-ray light. Now you can see a live image of the sample. This is the tissue of the heart valve. And here you see a liquid film around, because during all the investigation we have to keep the sample moist. And this is why there's a foil around. If you want to make a tomograph of a complete heart valve, there's a challenge to make a good image, because the metallic stent has a high absorption of the X-ray radiation, and the tissue has a very low absorption of the radiation. But it's possible with our system. We can make an image, a radiography, by clicking on this way. And now the system collects or makes an average for 20 seconds, and then we got an image. Okay, let's save it. And now here's the image. Here you can see the bubbles, it's just air, and the liquid film around. if you want to see the calcification on this tissue, we have to do an X-ray tomography, and then we got images like this. This is maximum projection of 900 slices of a 3D image in one plane. This bright circular object is the metallic stent, and this is all the calcified area. And then we can switch to a different angle of view. This is a circular cross-section around this area, and then we can see the calcified area from this angle. I hope this small introduction to MicroCT on heart valve bioprostheses aroused your interest. Now I'm ready to answer your questions. And thank you very much that you joined the lab tour.